This week in my class, we've been doing a lot of review about finding molar masses, converting between moles and mass. But today we're going to be looking at those overall larger stoichiometry problems and trying to figure out how to use those things to help us out. So I know there was some confusion when trying to figure out how to use this foldable. You can see here that I have labeled mass A, mole B, and mass B. And underneath, we have different things that we got to do to the numbers we're given to help us flow through these problems. But we really need to understand what these things on front mean. So when I say A, it's the compound that we're starting with. And when we have a compound, we could either start by knowing its mass or knowing its moles. And that's going to be where we start. So if we have to start with the mass, we have to convert it to moles, and then we can continue from there. When I say B, that will be the compound that we're trying to figure out. So that'll be the ending compound. And we could either figure out the answer in that ending compound in amount of moles or mass. And depending on where we're starting, either here or here, and where we're ending, it's going to be a different amount of steps. So commonly, I ask questions where we go from moles of A to moles of B, and that's just a moles conversion. In that kind of question, all we would have to do is convert between our moles using our chemical equation. And we could just use our coefficients there. But in some questions, I give you the mass of A, and I ask for the mass of B. And there's extra steps for these questions. You would have to convert the mass of A into moles. Then you would do the same step from the last problem, moles to whatever moles you want to find. And then you would have to convert those moles into mass. So it's good to know each of these steps and be able to recognize where you are in the problem so you can know what to do next. So we're going to take a look at a few examples, all using the same chemical equation here. So the chemical equation, I already gave you guys a balanced chemical equation, but I may give you a question where you have to figure out your coefficients on your own. But this time, it's already balanced. So we got 6 carbon dioxide plus 6 water react to produce 1 glucose and 6 oxygen. So let's go through some of these questions here. Let's go through this first question. It is asking if you have 32 grams of carbon dioxide, what mass of water will react? So the tricky part is finding where we start and where we end. So we are starting with 132 grams of carbon dioxide. That means we're starting with mass, because they're giving us grams, of A. That's what this is, our mass of A. And where we're trying to go is mass of water, and that will mean, we're going all the way to mass of B. So this is a full 3-step problem. We are going to be doing all of these things. So let's take a look at our first step here. It's tough to have all these things out. And maybe we'll back this up a little bit so we can see a little bit more here. So we got our question, and then we got this. We're going to be going through all 3 of these. So first, we need to take our mass of carbon dioxide, which is let's move this up a little bit more. We have 132 grams, and we want to get to moles. So to do that, we need to divide by our molar mass. So I'm hoping that you guys are experts at finding molar mass by now. You got to use that periodic table. I'm going to give it to you right now. For carbon dioxide, our molar mass is 44 grams per mole. So we are going to divide by 44 grams per mole, and we'll get 3 mole of carbon dioxide. So now that's our first step. It brings us to moles of A, 3 moles of carbon dioxide. If I flip these two up, because now I want to get to moles of water, it tells me how to get there. So I need to multiply by my coefficient on water on top and my coefficient of carbon dioxide on the bottom. So we'll put water up here and carbon dioxide on the bottom. And we could see water is 6, carbon dioxide is 6. So that balances out. It'd be 3 times 6 divided by 6, or it would be 3 moles of water. So now we're at moles of B, moles of water, but our question is asking for mass of water. So we still got to do something. So let's flip this up, see what we got to do. We need to multiply it by our molar mass, but it's not going to be the same molar mass of carbon dioxide. It's going to be our molar mass of water in this case. And if you look at the periodic table, that will be 18. So we'll just say times 18 grams per mole. And if you do all this, our answer should be 3 times 18 is 54. Our answer is 54 grams of water. That will be our answer for this question. But we don't always have to go from mass to mass. Sometimes it's a lot shorter of a question. So in this next question, it asks, if you have 2 moles of water, how many moles of C6H12O6 can you produce? So in this case, let's see what we're starting with. We're starting with 2 moles of water. So in this case, this will be our A, and we're starting with moles. So we're starting at moles A. And what it's asking us to get to is moles of glucose, or moles of C6H12O6. So that's actually just a one-step problem. We're starting here, we're finding here. So all we got to do is we're starting with 2 moles of water. And if you flip these up, the moles of what we want go on top. So that'll be the coefficient on C6H12O6. On the bottom is what we start with, water. And then we just throw our coefficients in there. So if there's no coefficient, that is 1. And water has a coefficient of 6. So this would be 2 moles of water times 1 divided by 6 would be 1/3 of a mole of C6H12O6. Let me move all this up so you can see it. Oops, I don't think you saw that the whole time. So that's what the work would look like. Let's do one more. So I don't do this very often, but it is good to know. There are also questions out there that may ask a kind of a combination here. So in this question, it's asking if you have 90 grams of water. So we're starting with our 90 grams of water. How many moles of oxygen can you produce? So here, you got to figure out where we're starting and where we're ending. So if you have 90 grams of water, we're starting with grams, so it's mass of A. So we're starting right here. 90 grams of water. And we're trying to get to moles of oxygen. So we're going, oxygen will be B. And we're just trying to find moles here. So we're ending here now. So we're just going to do 2 steps here. We don't got to do that last step where we got to convert to mass. So our first step is to go from mass of water to moles of water. So again, just divide by that molar mass, which is 18 grams per mole, which would give us 5 mole of water. And now we just have to convert to moles of oxygen. And we would just do this. Water on the bottom, oxygen on top. And if you take a look at our chemical equation, they're both going to have 6 there, which makes it really easy. 5 times 6 divided by 6 is just 5. 5 moles oxygen. And that would be our answer there. So I'm hoping this helps you figure out how to identify in your question, what do you start with and where to start on your foldable? Where do you end and where that's going to be on your foldable, whether it is moles or mass.